I totally agree.
So I'm going to record this and I'll shrink it.
Cool.
And maybe you can help me out a little bit here because I don't know how to take your horizontal photograph and rotate it.
Sure. Try clicking on the image. Just click like in the middle. Nothing.
Let's see. I got a bunch of things up here.
Yeah, try doing the...
Save, drive, print, download, share, zoom, details, pop out, close. I don't know how to rotate it. All my other programs in Windows Vista made it real easy to rotate it.
Yeah.
Not that I need to. I can figure it out. I can read it upside down. But in the future, if you could try to film it or take your picture so that it's vertical.
Sure. Do you want us to take like another photo?
Well, you can try that. Yeah, we'll go ahead and try it. Although, like I said, I can read these.
Did you do it vertically or horizontally?
Well, I just have to turn my head.
Okay.
For me to read that, I just have to look at it a little.
Yeah. I'm trying to think.
I can read the first one. Multiply the binomials. That's all I need to be able to do is read it.
Okay. I mean, I think it's under, like, in the bottom right corner.
All right. Times x minus 3. Do you want to start on 1? It looks like you've done quite a few of these.
I have, yeah. I just want to finish the ones that I didn't do. Like, the ones I didn't do, I didn't understand.
Tell me where you want to start.
Let's start on... What? Okay, my dad said he'll send it to you again, and then he'll rotate it.
All right.
Yeah.
Which,
let's start
I can make it out. Looks like you got through G.
Yep. Yeah. So we'll just start on H if that works.
Let's start on H.
Cool. Hey, Dad, can I have my paper?
Let's see. H is 10x cubed minus 31x squared plus 15x.
Yeah.
And what's the factor the thing completely? All right. Okay. Is there a greatest common factor? It's always the first question you should ask.
There isn't, because isn't 31 a prime number?
It is, but there's x.
So x would work, yeah.
Yeah, well, notice that this is a cubic. You don't know how to factor cubics. And in fact, factoring cubics is extremely difficult, about 5 times harder than factoring quadratics.
Okay.
So when you see a cubic, know that I can probably take an x out of that. Turning it into a linear, that's linear, the x. And what's left over, which is 10x squared minus 31x plus 15. That is a quadratic.
How would you get 10x squared, though?
Well, make sure that when you factor, you always never change the function. Multiply x times 10x squared, what do you get?
Oh, 10x cubed. Okay.
Multiply x times 31x, what do you get?
Just 31x. Okay.
Where?
That makes sense.
Tell them I sent it?
Yeah, my dad... Oh, yeah, my dad sent it too.
Okay, and then multiply x times 15, you get 15x.
That makes sense. Okay.
But what I've written is no different than what we started with. It's just factored. Now we have to factor this quadratic.
Yeah.
I don't know for sure whether that quadratic factors even. I'm going to have to play with it to see whether I can produce that quadratic by factoring it into linear terms. Well, what's a good starting spot to see if we can do that? We may have to use the quadratic formula. But I'm guessing not. I'm guessing that it does factor.
Okay.
So where's a good starting spot? First of all, the starting spot is always to break up that.
Yeah, so 10 plus x in both ones, right?
No, we need
All right.
two numbers that multiply together that give us 10x squared, and
So
we want to separate the x's. Because we want linear. So how about let's try 5 and 2.
5 and 2x, yeah.
Notice that those two multiplied together give you 10x squared. That's the rule. You need that to happen, okay? Now, the next step of factoring is to examine that sign. The fact that it's plus means what about the signs on the bottom? What do they have to be?
That's going to be positive.
Well, they have to be the same.
Or the same, yeah. To get a positive number.
There's different, right. Either they have to be plus plus or minus
or
minus.
Negative. Yeah.
What are they in this case?
Plus plus.
Produce a minus 31x as the middle term.
We would do subtraction and then an adding.
They're minus minus. No, they're not minus plus. They're minus minus. When you are factoring, the second step is to figure out both signs.
Okay.
Don't forget that second step. Every one of my students does not want to do that step. And that's what leads them to problems.
Okay.
Okay? Now, what are factors of 15? And we can't even make the statement that factors of 15 have to add to 31, because that's no longer true when you have a coefficient in front of the x.
No.
But I still need factors of 15. There's only one way I'm producing a plus 15, and that's if I have factors of 15. Well, let's try 5 and 3.
Yeah.
Okay, always try your two closest factors. That's the most likely answer.
Okay.
What middle term would this produce?
Okay, so it'd be 10x squared.
No. Hold on. The middle term comes from multiplying that times that. What is that?
So negative 10x.
And then multiplying the outsides. What do you get when you multiply minus 3 times 5x?
Negative 15x.
Add those together.
You get negative 25x.
That's not the correct answer then.
No.
So there's there's a couple of other choices. We don't know. The choice might be 15 and 1. But that's not what we're going to try. We're going to try 3 and 5. In other words, we're just going to move the 3 to there and try 5 there. Okay. Now let's see if that produces our middle term. What's that?
So negative 6x. And then negative 25x. And you get negative 31x, which is what you want.
That's the answer, which means that is the correct factoring.
Cool.
So we can erase all of that. Factoring is a lot of trial and error.
It is.
You just have to do trial and error. I mean, they could have given us a problem where this was 10x and that was 1x. And that was 15 and that was 1. But that's pretty rare. The Colorado school system doesn't tend to do that. The Colorado school system tends to give you the factors that are closest together. Yeah. So that's fully factored. Cool. And that's a linear term, that's a linear term, and that's a linear term. Linear because the power of x is 1 in each case. Okay. In other words, this term up here was a quadratic term. Quadratic terms you can factor. Yeah. Linear terms are the basic, the bottom. Once you get it down to linear terms, you've got it fully factored. Cool. Okay. If I were to multiply these three things together again, I would get back to this. That's the key. In other words, if somebody said to you, your life depends on this. If you get this answer wrong, you're going to be dead. But what would you do? You would make sure you multiplied these three back together again to make sure you got what you started with. And that would be the way you would ensure that your answer was correct.
Yeah, I would make sure the problem's correct.
Yeah, absolutely.
Yeah, for sure.
Let me see if I got another email. Yeah, I did.
Cool.
All right, that's better. I don't know
Awesome.
what your dad did to change it, but
I don't either, but it works.
he took it vertically instead of horizontally, maybe.
Probably. I kind of switched it.
Does he have an iPhone?
He doesn't. He has a Samsung.
When I have a Samsung, and if I want pictures to come out vertical, I have to do it horizontally.
Interesting.
I have to hold the phone horizontally. And I believe iPhone is the other way around. I believe iPhone, you have to hold it vertically.
I believe so, yeah. Interesting.
Yeah. And I get that problem every now and then, and it's only become a problem since I got Windows 10 because I can't figure out how to rotate it in Windows 10.
Oh, it's so confusing. They just made it even more confusing.
No, that's an undo. But a lot of these problems have things that let you rotate it, but I can't figure out how to rotate a JPG file.
Right.
But that's okay. I don't need to anymore. So let's take x squared minus 81.
Okay.
There's a name for that. What is that called? There's very few quadratics that have a name.
Okay.
And yet, this one you're going to get 100 times in the next year. So it's good that you can recognize it.
Yeah.
It's called difference of perfect squares.
Okay.
Notice that x squared is a perfect square. That's x times x.
And 81's a perfect square.
81 is a perfect square. That's 9 times 9. So when you have the difference of perfect squares, a squared minus b squared, it always factors into a minus b times a plus b.
So would it just be x minus 9 and then x plus 9?
You got it.
Cool.
In other words, it's the square root of x squared, which is x, minus the square root of 81, which is 9. So the first term is always that, and the next term is always the conjugate of it.
Okay.
You don't even have to think about the next term. Once you get the first term, and always put the negative in the first term.
Yeah.
That might sound strange, but I have a reason for that.
Okay.
Okay?
Cool.
In other words, some people will tell me x plus 9 times x minus 9, which is just as correct, but it doesn't help when you go to memorize difference of perfect cubes or sum of perfect cubes.
Yeah.
Whereas if you memorize it this way, it's going to help a lot in doing other problems.
Cool.
So 4x squared minus 25, what's that called?
That's called, they're both perfect squares, so it'd be the
difference of perfect squares.
Difference of perfect
squares. The subtraction is the difference. That's a perfect square, that's a perfect square. So how does this factor?
Just 2x minus 5 and then 2x plus 5.
You got those.
Awesome.
(16x squared).
Same thing, difference of perfect squares.
49y squared. Both of those are perfect squares.
So it'd be 4x minus 7 and 4x plus 7?
4x minus 7y. Don't forget the y.
Yeah, my bad. Yeah.
In other words, the square root of that is 7y.
Okay.
And then the second part, you don't even need to think about. It's just the conjugate of that, so it has to be 4x plus 7y.
Awesome. Alright.
18x cubed minus 32x. When you are doing factoring, the very first step is to always look for the greatest common factor. Now, none of these others had a greatest common factor. I could not take a greatest common factor out of any of the 3 previous problems.
No.
But this one I can. What's the greatest common factor?
For this one, it would be 9.
9 doesn't go into 32.
9 times, yeah, 36.
Well, not it's what's the biggest number that divides into 18 and 32?
4. No, 4 doesn't go to 18.
Divide into 18. They're both even numbers.
Does 6 go into 32?
No.
So just 2. Yeah,
Just
2 would be the one, yeah.
Also a variable. What's the variable that you can take out?
Just x cubed?
Just x.
Or just x, yeah.
In other words, I can factor out a 2x. What do I have left behind?
So you have 2x. How would you get 2x? Like, I'm just kind of confused on how to...
Okay.
Would you just...
First of all, you figure out the biggest number that divides into both of those numbers.
Okay, so that takes out a
2 is it. 4 doesn't. 9 doesn't. There's no other number that divides into 18 and 32. 2
So
is
just
the biggest one. It's the greatest common factor.
Okay.
And x is the greatest common variable.
Mm-hmm.
In other words, I have to be able to divide both terms by that and get an integer.
That makes sense. Okay.
Okay, that's the secret. When you get greatest common factor, it has to divide into both terms. Now, what goes here? What is 18x cubed divided by 2x?
9x squared.
What is 32x divided by 2x?
16.
Now, what is that called?
That's called difference of perfect squares.
So how does it factor?
So now it would be, so 2x parentheses.
Hold on. Square root of that. Yes. You carry the 2x down, but the problem is now figuring out how to factor 9x squared minus 16.
Yeah, so it'd be 3x in both parentheses.
Just do
minus 4 and then plus 4.
The only thing, you don't need to treat this like a normal factoring problem, because if we can get the first one, we know what the second one is. It's just the conjugate. So what's
exactly.
3x minus, it's always minus for the first term, what?
4.
Yeah. Now we don't even have to think about the second one. It's got to be 3x plus 4.
Exactly.
So that's how it factors.
Okay, cool. And then for n, the greatest common factor would be 6.
No.
Would that be? No.
12. Notice there is no number or variable that divides evenly into every term.
Yeah.
1 does.
1 does. So just be x, parentheses.
No, x doesn't either.
Oh, x doesn't either. Yeah.
There's no x over here. X does not divide into 36 evenly.
So just 1.
Well, that means there's no greatest common factor.
Yeah.
So we have to factor this like a normal quadratic.
Okay.
Split the x's up. What do you get?
So you get
Split the
x
x squared up.
Oh, okay. So x and then x.
Second step, what do you do?
So you have to find a number that goes into 12.
No, everybody wants to forget the second step, and that's what everybody's problem with factoring is.
If it's adding or subtracting.
No. Figure out both signs. That's the second step. If you figure out both signs, the rest of the problem is going to be easy.
Okay.
But if you skip that second step, the rest of the problem is going to be tough.
Okay.
What are the signs? What must the signs be to produce a plus 36?
They have to be both positive.
Or both negative.
Or both negative, yeah.
They have to be the same. So it has to be plus plus or minus minus.
Okay.
This tells you what it has to be right there. Plus plus.
Yeah.
If this term was a minus, then it would be minus minus.
Minus minus,
so once you determine that the signs have to be the same, they are whatever the sign of the middle term is.
Okay.
Now the third step and last step is factors of 36 that add, because of that plus sign, to the number 12. Well, what factors of 36 add to 12?
Let me think here.
What's
6 times 6.
Yeah, two numbers that multiply to 36 and add to 12. That's it. And that's the answer.
Cool. Awesome.
Right there.
Cool.
Factoring is really quite easy as long as you don't try to use what they teach you in school, which is the California method, which makes it complicated and very confusing. Factoring is not tough, but
no.
I have so many students that have so much problem with factoring. And I teach my own method of factoring because I think it's the best method. It's not because I want to be different. It's because it's the simplest, most straightforward method. What's the first step? There's going to be 3 steps in this problem. What's the first step?
So the first one will be x squared, so just be xx.
Xx. That's the first step, is to break that up. Because it isn't always x squared. Sometimes it's 2x squared. And if it was 2x squared, it would have to be 2x times x.
Exactly.
So you have to break up that first term. You have to split it up. Now, what's the second step?
So it's a minus 10x, so it'd be minus positive.
Nope. You look at this sign right there.
So
how can I produce a plus 25? Remember that this term comes from multiplying that by that. Always. Nothing else. The constant comes from multiplying the last term of each linear factor. So how am I going to produce a plus? What will the signs be in order to produce a plus sign? Have to be the same. If I had a plus and a minus, that would be a minus. Right? When you multiply a plus by minus, you get a minus. So the only way you can possibly get a plus is if the signs are the same. They either have to be plus plus or they have to be minus minus. They have to be the same. And that's a key step in factoring. Now, we know they have to be the same. What are they? Well, look to the middle term. What is that?
So minus minus.
Minus minus, exactly.
That makes sense.
Now we need factors of 25.
That added to negative 10.
Just add to 10. You don't need to exclude the sign. Yeah, 5 and 5.
Cool.
And let's check it. The checking process is very important. And I'll tell you why. It's not as long as you think. First of all, we do not have to check the x squared term. The way we did our factoring, we know it's x squared. And we don't have to check this term over here. The way we did our factoring, minus 5 times minus 5 gives you that plus 25. The key term to check is the middle term. Well, what produces the middle term? It's the inside and the outside. Do you know FOIL?
Briefly.
Well, it's those two terms that produce the middle term only. First term isn't involved, the last term isn't involved. But the middle two terms are. So what's the inside produce when you multiply it together?
Negative 5x.
What's the outside produce?
Negative 5x.
Add them together.
Negative 10x.
We got our answer.
Cool.
And that's all you have to do to verify that you have the right answer.
Cool.
Is to multiply the inside and the outside, add them together.
Awesome.
Factoring when the coefficient of that is 1 is a piece of cake. It's only 3, at most 4 steps. But if you skip any of those steps, you're going to be in problems. Don't skip any of them.
Awesome.
All right. Now we're going to tackle a more difficult one.
Yeah.
Why is it more difficult? Because it's not a 1.
No.
There's a 9 in front of that, which
Mm-hmm.
means there's more possible ways to factor it.
Yeah.
In other words, the very first thing, and notice I cannot take any greatest common factor out of that.
Uh-huh.
There's no number that divides into 9, 60, or 100, and 100 rather. 3 doesn't, 10 doesn't, so there's no greatest common factor.
No.
So we're going to factor it normally.
Okay.
Now, how do you split up the 9x squared? That's
3x in both.
That's the best thing to start with. Doesn't have to be the right answer. It could be 9x and x.
Uh-huh.
Notice that if it was 9x and x, that would multiply to give you 9x squared.
It would, yeah.
So this is a trial and error process.
Uh-huh.
What are both signs?
So they're both going to be positive.
Good.
Cool.
What are the most likely factors of 100?
10 and 10.
We'll try that. Like I
I
said,
don't think that works.
it's a trial and error process. Well, let's see if that produces the middle term. What's that and what's that?
So 30x and then 30x.
Add them together.
60. That works.
That works. That's our answer.
Cool. Awesome. Alright.
49x cubed. Now, the moment we see a cubed, be aware that we're probably going to be able to factor an x out.
Yeah.
Because they have not taught you how to do cubics. And trust me, doing cubics is not easy. But once you can reduce it to a quadratic, it is easy.
Okay.
Usually. So what's the greatest common factor I can factor out of that?
7. Well, no, because 7 doesn't go to x. So just 1. No, x.
Just x.
Yeah, because x can go to all of the
I can
numbers.
take out of there. X goes into every term evenly. What's the first thing? What's this term here now?
7x squared?
No? If I did that,
yeah.
Always be checking. Always be checking to see that you haven't changed it. What is x times 7x squared?
7x cubed.
That's not 49x cubed, is it?
So it'd be 49x squared.
49x squared.
Yeah.
The secret of math is to always be checking to make sure you have not changed it. What goes here?
Minus 14x.
Does x times minus 14x equal that? Yeah, it does. So you did it right.
Cool.
Finally, what's the last term?
Plus 1.
Okay. Now we have a linear factor and we have a quadratic. That quadratic probably factors nicely. Where's a good starting spot?
7x for both.
What are both signs?
It would be both minus.
Good.
Cool.
And what are factors of 1?
1.
That's it. No choices even. Does that produce the middle term correctly?
It does, yeah.
It does. That's our answer.
Cool. Awesome.
All right. S gets a little bit harder.
It does. Mr. Magus, like my math teacher, said we were going to be going over these 4 problems tomorrow. Like, he's going to show us how to do them.
All right.
Because we haven't learned quite yet how to do these.
I can maybe get you started a little bit.
Sure.
Notice that it's a quadratic. What's my first step?
So X for both.
What are my signs?
X, Y.
No?
Oh, I'm sorry. Yeah, it's both plus. My bad.
Okay.
Yeah. Yeah.
Now, there has to be some number of y in the last term.
Mm-hmm.
So let's just guess and say 4y and 2y.
Okay.
Okay?
Okay.
Now, that's going to produce the x squared.
Uh-huh.
What kind of middle term is going to get produced?
4yx and then 2yx. So you get 6yx.
Which we don't have in here.
No, so that won't work.
Okay, let's erase that.
Mm-hmm.
And try 8 and 1. That's really the only other thing.
Yeah, that'll work. Because you get 8yx.
That gives
Well, actually,
yx. It doesn't really work.
no, because you get 9xy, or 9yx.
Right.
Yeah.
How are we going to get 1xy and 8x?
Um,
I'm going
maybe 2 and 4,
ignore
like
those
flip them.
problems and let your teacher explain how to do them.
Sure.
Because quite frankly, I'm not sure how to do
Yeah,
them.
me neither. Well, could we try 2yx, or 2 and then 4? Like, just switch them around?
Well,
Nah, you'd
notice
still get
if
the
I
same thing.
try 2 and 4, I'm not going to produce 1.
No.
In other words, I'm going to have a 2xy and a 4xy, which
Yeah,
are never going to add together to be plus 1xy.
No.
So I quite honestly am not sure how to do this.
Mm-hmm.
Yeah, rather than wasting your time trying to have me figure it out, I'm going to let your teacher figure that out. Next time we meet, you can tell me how you did those.
Definitely.
We've got some more problems here. Let's solve the following quadratic equations by factoring. Okay. These kind of problems, these 4, those are very, very high level algebra. That's even beyond college algebra.
That looks, yeah.
And you're taking geometry. So there's no real reason for you to have these problems. I'm curious as to how they're done.
Me too.
I'd have to think about it for a while, but I'm just going to let your teacher tell you how to do those 4 tomorrow. So let's go to 3.
Cool.
What's the first thing I can do with 3a?
So 3x for both.
Greatest common factor. Always consider that. That's always the first step.
6 would be.
How about 6x?
6x, yeah.
In other words, I can divide that by 6x and get an even number, and I can divide that by 6x and get an even number. That's the key in factoring, is can your greatest common factor divide into both terms?
Yeah.
Yes, it can.
Yeah.
What's here?
So it'd be 6x parentheses 3x.
Does 6x times 3x give you 6x squared?
No, so just 1x.
There you go.
Or just x, yeah.
That's why it's so important to check at every step.
For sure.
Plus what?
So it'd be x plus 5.
Okay.
X.
Not
just
5
5 actually, yeah.
5.
Yeah, just
6x times 5 is 30x. All of that's equal to 0. So how do we solve it from here? When you have two numbers multiplied together that are equal to 0, one of them has to be 0. So what's the next step? Either that has to be 0 or that has to be 0.
So would you divide?
Well, let's set those down. Either 6x has to be 0, or x plus 5 has to be 0.
Oh, that makes sense.
That's the next step, is to set each one of them equal to 0. Well, if 6x is equal to 0, what is x?
0. 0 over 6.
And if x plus 5 is equal to 0, what is x?
X is equal to -5.
There's your two solutions.
Cool.
In other words, if either of those solutions is true, then that's true. Because I would have 0 times a number, and 0 times a number is always 0.
Yeah.
One of the most important fundamentals of algebra is that concept. And if you have three numbers, in other words, if I tell you that A times B times C equals 0, well, one of those three numbers, it has to be 0. If I tell you A times B times C times D has to be 0, one of those four numbers has to be 0.
Yeah.
Important concept in algebra.
Cool.
All right, the next one. X squared plus 11x minus 26 equals 0. First step.
Okay, so x would be in the both.
What do the signs have to be?
Both gonna have to be positive.
How do you produce a negative? In other words, the thing we're looking at is that negative right there.
Yeah, so they'd have to both be negatives.
No, two negatives would produce a positive.
So a negative and a positive.
Exactly. They have to be opposite.
Yeah.
So they have to either be plus minus or minus plus. But as long as the coefficient on the x is the same, minus plus and plus minus are the same thing. So I don't have to allow for both. I can just write plus minus.
Okay.
Okay. Now, the third step, we've done the first two steps, which is to split up the x's and figure out both signs. That's always the first two steps.
Okay.
The third step is factors of 23 or 26 that subtract, because of that minus sign, to the number 11. Well, what are factors of 26? We'll start with 26 and 1. What's the next one?
13 and 2. Which that would work.
That works. Now, there is a fourth step. Whenever this is a minus sign, you have to figure out which number goes with the minus and which one goes with the plus.
Okay.
So the fourth step is to take the larger of your two factors, which is 13, and put it with the sign of the middle term.
Okay. Yeah.
So the 13 goes there.
That makes sense.
The 2 goes there.
Cool.
Let's check. That's 13x. That's minus 2x.
You get 11x.
Get 11x.
Awesome. And then you equal that to 0. And then it would be x plus 13 is equal to 0, and then x minus 2 is equal to 0.
Correct.
And
So what is your solutions?
X is equal to -13, then x is equal to 2.
Good. And it's as simple as that, okay?
Yeah. Okay.
Factoring quadratics is extremely simple as long as the coefficient of the x squared is 1.
Yeah.
It becomes a little more difficult when it's not 1. Now notice it was 6 on A.
Yeah.
But we factored out that 6. In other words, we were able to take that 6 away, and what I was left with was x squared plus 5x, which I could factor.
Yeah.
So, but the next problem, hold on, is 2x squared minus 5x equals 18. Well, what's the first step almost with all quadratics? particularly quadratics that have an x squared and an x term.
Greatest common factor.
Not quite.
Okay.
What's common about the first two? They're all equal to 0.
Yeah, this one's equal to 18.
Yeah, so let's get it equal to 0. That's the first step.
Okay.
So how can I do that?
So we could do 2x squared, subtract 18.
You got it.
Yeah. Is equal to 0.
Now I got it equal to 0. Now it's just like any of these other problems.
Yeah.
Okay. The only difference is this is a harder problem.
Uh-huh.
And the reason it's harder is because of the fact it's 2x. Well, let's break that up. There's only one way to break that up. What is it?
2x and then 2x. Actually, no, just 1x.
Well, yeah. If I wrote 2x and 2x, that would produce a 4x squared, which we don't have, so that can't be the solution. But if I break it up into 2x and x, that's going to produce 2x squared.
Uh-huh.
Okay. Now, what are the signs?
They're both going to be minus.
If I had two minus signs, this would be a plus.
So it'd be plus and minus.
Yeah, it has to be opposite. You cannot produce a negative constant unless your signs are opposite.
Uh-huh.
Okay?
Yeah. Okay.
The question is that plus minus, in this case, is not quite the same as minus plus.
No.
So I write both.
Okay.
Now it's just a question of trying factors of 18.
Uh-huh.
Well, how many factors of 18 are there? There's 18 and 1. What else?
2 and 9, 6 and 3. That's it.
But notice how I got those. I cut 18 in half and doubled the other one to get 9 and 2.
Yeah.
And then I divided 9, I cut it by a third, and multiplied the 2 by 3.
Uh-huh.
That's always the way you can factor. Is just keep chopping down one and increasing the other by the same amount.
Mm-hmm.
Now, which ones are we going to... This is a trial and error process.
Yeah.
Which one should I try first? The two that are closest together.
3 and 6.
That's a good place to start. I'm not saying that that's the answer, but that's where I'm going to start.
Yeah.
Okay, now, the key here is to figure out what the middle term is produced.
Mm-hmm.
And if that's our middle term.
Yeah.
What's the inside smiley face?
That would be 3x, and then the outside would be negative 12x. Yeah.
The outside is what?
Negative 12x.
Negative 12x. What do those add to?
Negative 9x. So that won't
Got the wrong number. Okay?
Yeah. Uh-huh.
If I were to move the 3 down to here and the 6 down to there, we would still get 9. It would just be a positive 9x.
Yeah. So
So there's no point in trying that solution. We know that's not going to work.
Yeah.
But
So
what might work is if I put the 6 on the left,
and then 3 on the right.
3 over there. Let's see what number that produces. Well, I can see it produces plus 6x, minus 6x. It doesn't produce anything.
No.
0.
Yeah.
So let's go to the next most likely factor.
9 and 2.
Yeah, let's try it.
Okay.
What's that produce as a middle term?
9x and then negative 4x.
Put the sign on it. I don't like it when you say 9x. It's plus.
Oh, my bad.
Because
so
we need to know what that sign is.
Yeah, and then minus 4x.
Okay, what do those add to?
5x. So we just need to switch them around.
5x, right. Now we got the right number, but the wrong sign. Well, to get the right number and the wrong sign is all I have to do is move the 9 down to there and the 2 down to there, erase those,
And there's your answer.
The middle is going to be minus 9x.
Mm-hmm.
Outside is going to be plus 4x. And that's going to produce a minus 5x in the middle, and that's what we have in the middle. So we have found how to factor this thing.
Yeah.
And like I said, it's a trial and error process. But no matter what method you use, even if it's the California method, it's a trial and error process. So there's no escaping the trial and error nature of factoring.
Yeah.
You just have to keep trying different factors until you see one that works. And, and you're always trying to produce the middle term, always.
Yeah. Yeah.
Now, what's the solution?
2x minus 9 is equal to...
quadratic equations by factoring. So we've factored, but we haven't solved the quadratic yet.
No. So it would be 2x minus 9 is equal to 0.
Or?
Then you would... Or 2x plus 9 is equal to... Or x, yeah. X plus 9 is equal... Or x plus 2 is equal to 0, yeah.
Okay, what's the solution of the first one? Now, let me just say something. Both of these don't have to be true. One of them has to be true.
Yeah.
You cannot produce 0 unless one of these two terms is 0. And when you're dealing with a typical quadratic, both of them are true. But there are other types of equations that involve square roots or logarithms or absolute values where one of these equations might not be true. Okay, what's the first one produce for a result?
X is equal to plus 2x 9 divided by 2. 3.5.
No, you can leave it like that. You don't need to do that. Yeah, in fact, this is actually a better answer. Than 4.5.
Yeah.
4.5 is hard to work with. Ratios, fractions are easy to work with. This one is what?
-2.
All right, so that's your two solutions. Now, like I said, you might run into a quadratic where one of these two will be an extraneous solution, meaning it's not a solution. If I were to plug 9/2 in for x up at the top, that's going to be a true equation.
Yeah.
If I were to plug in -2, it's going to be a true equation. So both solutions are correct. Normal quadratics do not tend to produce extraneous results. The kind of equations that might produce extraneous results are if there's a square root in the equation, if there's an absolute value in the equation, or if there's a logarithm in the equation. So if you see one of these, you need to check both solutions and make sure they are legit. But if you don't see one of these three things, if you just see a normal looking quadratic, then you probably don't need to worry about extraneous solutions. Okay?
Cool.
Because, like I said, the rule is that when you multiply two things together, one of them has to be 0. There's no rule that says both of them have to be. We always set each one of them equal to 0 and come up with a solution, but then technically we should try each of these solutions to make sure it works. But I've been working with this stuff for a long time, and regular looking quadratics do not produce extraneous solutions.
No.
You need a square root in there, or a cube root, or a logarithm, or an absolute value, and then you might have an extraneous solution, and you would want to check both solutions. But in a normal quadratic, you're fine. Once you get your two solutions, you can be 100% certain that both of them are correct.
Cool. Awesome.
So, I'm glad we got a chance to practice factoring, because you can never get too much practice factoring.
No.
Factoring is a huge skill that you need, You're going to need it on the ACT, the SAT, and in algebra.
Yeah.
If you take Algebra 2 next year, factoring is huge. So
For sure.
work on your factoring ability. There's few math skills that are more valuable to you than being able to factor a quadratic.
Mm-hmm. Cool.
All right.
Awesome.
Dylan, you have a good night. And let's see. Let me just check my calendar here.
Sure.
I think we have a session scheduled. No, not this week again.
Okay.
So I will talk to you probably next week.
Sounds good. Awesome.
All right.
All right.
Bye.
Thanks, Mr. Cohen.
Sure.
All right. Bye-bye.
Bye-bye.